In this video, we're going to take a look at an example of about how to add vectors together. And we'll start off with these two vectors A and B. Now, just to make it easier to draw, I used the grid system in order to make sure that things were lined up well. So really, what one could think about is that if vector A takes me 10 units along the x-axis and then 5 units along the y-axis, then how far is this? So really, vector A is the sum of the x component and the y component. And you can see I've actually drawn them as vectors, and I've added them tip to tail. So when we have x and y components, the purpose of this little graphic here is to show us how we can get to magnitude and direction. Magnitude would be how long it is, and direction would be this angle measured from the x-axis. And so to do that, obviously, I'm going to need help from my calculator, but I want to start off by making sure I'm in degree mode. So I'm going to just go and check that, because I might have been doing stuff earlier in radian mode, but that's not the case. So I'm in degree mode. Okay, well, this is saying if I want to go from x and y to magnitude and direction, I can use the Pythagorean theorem to find out the length of this hypotenuse. So that's going to be the square root of 10 squared plus 5 squared. And so 11.2. And these units are arbitrary because they're just points on my graph paper, but they could be anything like meters per second or forces, lots of choices there. So 11.2. And then let's do the angle. So the angle says inverse tangent of the y part over the x. Here's the y part. So inverse tangent of 5 divided by 10, which is just 0.5 anyway. Okay, so 26.56. I'll round that off. Let's just call it 27 degrees. And here's how we'll indicate, because there's lots of ways to draw 27 degrees on this coordinate axis. So I'm going to write 27 degrees above plus x. Okay, that takes care of that. We'll do the same thing for our b vector. B is 5 and 15. So the calculator doesn't really care about the minus sign. I'm just going to disregard that. So I'm going to go back here and I'm going to type in, we've got 15 on the x-axis now. And I'll be curious to see what that winds up doing to the magnitude and direction. So yeah, the magnitude is bigger. So that's 15.8. And then we'll do the angle. So I've already done that operation before, so I'll just bring that back. And so this is 5 over 15 instead. Let's see what that does to the number. Yeah, 18.4, so it makes it smaller. And so this angle is 18 degrees. And now above minus x. Great. So if I'm going to add these two, I'm going to draw them tip to tail. And I'm going to swap out and take a look at a simulation really quick just to see what that's going to look like. So this is at the PHET website. And you can click and drag these vectors around. So as long as it still has the same length and the same angle, it doesn't really matter. We would say that the identity of the vector is preserved under the operation of translation, which is, just means you can click it and drag it around and it still stays the same. All right, so if I want to add A to B, here's what I'm going to do. I'm going to draw A, and then I'm going to put B right next to it. So the sum, well, A takes me to the right, but B takes me to the left. And A takes me up, and B also takes me up. Okay, so let's see what that's going to look like then. I'm going to click on the sum, and we'll see what that is. Here's the sum, and you can see if I put that there. the sum starts at the origin of the first vector and ends at the tip of the second one. Right, and you can see this is the answer up here. Okay, well, how do you get it? Well, graphically, we could do it, and I drew the x components and the y components in two different colors because when you add them, you can only add like components. You can only add apples to apples and oranges to oranges. So if I follow the steps, A takes me over to the right, and then the y component takes me up. And then for B, so this is y. And let's see what else is next. So for B, it's going to carry me back 15. So this is bx. And then y is going to carry me up 5 again. That's by. So again, to find the sum of these two vectors, I want to start off. I'll do this in a different color just so it stands out a little bit. But here's where I started. This is the origin. And then this is the sum of A plus B. Which we'll give it a name. Let's just call it B for Victor. I don't know. And that's equal to the vector A plus B. Right, so when we see letters with these arrows toward the top, we know that they're important. Right, so that's fair enough, but how do we actually, get to an answer? And I have sort of a tried and true way that most students find helpful, and that involves building a table. We'll write down what the x components are for each of the vectors and what the y components are. Then we'll write down the components for each vector. And for B. And so I already know what the components are. So this is going to be 10 and 5. It's going to be negative 5. Oops, negative 15 rather. And 5. And since these oppose each other, I'm going to take the difference. Okay, now what are these two numbers? Well, these are the x and y components of my answer. And so now I can go ahead and do the math. And that means that the magnitude of vector v, and here's how you write magnitude, is equal to 5 squared plus 10 squared. And then take the square root of the whole thing. All right, and the angle is going to be equal to inverse tangent of y over x, and the y value is 10. And I like to be positive, so let's just keep the positive and let's see how this comes out. Whoops. All right. I don't know what I'm doing here. All right. So inverse tangent of 2 and 63 degrees. And again, we should take the ambiguity out by specifying exactly where that angle is from. It's above negative x. Okay, and that looks about right. 63 degrees. Yeah, that sounds good. And then, of course, I didn't finish this off, but that's easy enough. All right, plus 10. Squared.